start is to explore finding the equation of a tangent line by exploring slope as we knew it previously. So in the past, we would find the slope by taking point A and point B and finding the difference between them and then dividing them, y over x, rise over run. So we're going to do that same idea now. So to find the equation of a tangent line to a parabola at a point. So we know we have the curve y equals x squared, and we know we're investigating the point 1, 1. So if you think about the curve, y equals x squared, we know it's a U-shaped parabola. If you think about the point on the curve, 1, 1, we're talking about this point here. So what we want to do is find an approximation to the slope by choosing a point Q on the parabola and computing the slope near point P. So right now, point P is my 1, 1 point. So what we're going to do is use point Q. So we'll make up a point Q. And point Q could be here to the right of point P. Technically, point Q could be here to the left of point P. It really doesn't matter. Point Q could be anywhere but at P. And if you think about finding the slope from point P to Q, no matter which of those points I pick, so the slope would go through the green and the blue, or the slope would go through the purple and blue. What can you say about the slopes of those lines I drew in? They're always what?
Linear.
What?
They're linear.
Yeah, they're linear, but remember slope, so linear goes with slope. Is the slope increasing or decreasing? Is it positive or negative? Those are words we would want to put with slope. So the green line and the purple line are both what? Increasing and or positive. So if we're talking about the slope between P and Q, we are looking for it to be a positive and increasing. So we're going to select Q to be 2, 4. So that's more like the purple example. So then if we find the slope of the perfect purple example, the slope of PQ would be 4 minus 1 over 2 minus 1. So you get 3 over 1. So does that meet my desired or anticipated slope? Yeah. It's increasing and positive. What if I get my point closer to the original point? So again, think about limits. What did we do as we found limits? We got closer and closer to the actual point we were trying to find. So if I pick a point Q now that isn't the purple and it isn't the green, but is rather closer to the blue, so now we're talking here. What do we think is going to be different? Is the slope going to be the same as it was at Q? Do we expect it to be larger or do we expect it to be smaller? Okay, so we have one vote for a little bigger. And we have a whole lot of quiet. So let's find the slope at PQ, where now Q is 1.5, 2.25. So 2.25 minus 1 is 1.25. 1.25 over 1.5 minus 5 is like 1.25 times 2. So 2.5. So as we got closer, the slope is less steep. And if you think about the curve, if you're looking at these 2 points versus these 2 points, that should make sense. There's less steepness to the curve. My slope is getting more accurate to the actual slope of the line. Let's get even closer to point P. So now we have 0.21 over 0.1. So you could just move your decimals each to the right too. So you get 2.1. So it's really like 21 over 10. So what do we predict the slope of the curve is at 1, 1? So I went from 3 to 2.5 to 2.1. So more than likely the slope at 1, 1 is 2. So this suggests that the slope of the tangent line at point P should be 2. In general, we say that the slope of the tangent line is the limit of the slopes of the secant lines. So today we're going to learn what is a secant line, what is a tangent line, and why are they useful. So if you actually took the limit of that problem, you'd have the limit as x approaches 1, because that's the point we're getting close to from the left and the right. So again, go back to the drawing. The point we're getting close to from the left and the right is at 1, 1 to the curve x squared. So you have x squared minus 1 over x minus 1. And again, there's some algebra that would have happened in there where you had x minus 1, x plus 1, all over x minus 1. Take away your whole, you get x plus 1. So limit as x approaches 1 of x plus 1 is 2. So to find the equation of the tangent line using the point 1, 1 and a slope of 2, how do you find the equation of any line? Given point and slope, we use point slope form. So if you know a point and you know the slope, you plug into point slope form. So today we are going to be writing many equations of lines.